All right. I'm sorry I'm not going to be here for these notes, but hopefully this is stuff that you guys have already seen before, and it goes smoothly. So I'm going to go through, these are the notes that are on Canvas. I took off the guided notes since we won't have a chance to go through those together. So this is going to be your best resource to figure out anything that you may have forgotten throughout this unit. So this is only dealing with one variable statistics. We'll get to bivariate next year. Mean, median, and mode. These are all measures of central tendency. Mean is just your average, so you guys have been doing that for years, that's nothing new. It shows me how to find it. You guys already know how to do that, plus our calculators can do that for us. The mode is just the number that happens most often, okay? No trick to that. And then median is if you put it in numerical order, it's what falls exactly in the middle. If there is an odd number, or sorry, if there's an even number, you will have to average the two together. If there's an odd number, it just is what it is. That's it. I do want to point out that mode, the calculator does not show you mode, so you will have to kind of look through and see which one occurs most often there. Alright, to find mean and median and a bunch of other stuff that we like, we can use our calculators. So if you hit Stat, Edit, and that opens your list, your L1, we can type in any amount of data points that they give us. Once we type all of that in, go to Stat, over to Calc, enter on one variable statistics, and when you do that, all kinds of good stuff is going to show up. Okay, this guy's going to be at top, X bar, that's my mean. Okay, standard deviation, it's a lowercase sigma, kind of looks like a circle with a little line on the top of it. I have my lower quartile, my median, my upper quartile. It also tells me my min, my max. A couple other things that we won't really use that much in here. These are the guys that you're going to want to pay attention to. Okay. There's no reason not to use the stat button to do this. Use your calculator. You can do it by hand, but why make more work for yourself? Also, standard deviation. You don't want to do that by hand. That's going to be a super long process. Okay. Alright, so sometimes we have frequencies. A lot of times you will get a table that looks like this. What this means is you had 8 kids who were 14 years old. You don't want to have to type 14 in 8 times. So when we have a frequency list on our calculator, we're going to put this guy in L1 and this guy in L2. Okay? Then when we ask it to find one var stats, if you have a newer calculator, it will prompt you. It will say XList. And then it will say frequency list. If that's the case, just type in L2 here. If you have an older calculator and it doesn't ask you for these, it will just pop up and say one var stats. You will need to type in L1, comma, L2. The comma is right above the 7 on your calculator. So again, if it doesn't prompt you for this, you've got to just type it in with a comma in between. If you are getting different numbers than your neighbor is getting, one of you probably has a frequency list and the other doesn't. Okay? So just be aware of that. Alright, that's just telling you everything that your calculator does. I'm actually going to go back up to these guys because we didn't really talk about what they meant. So lower quartile and upper quartile. Quartiles are exactly what they sound like. They split my data into quarters, into 25%. So you have what's called a 5-number summary. And that's going to be my minimum, my Q1, my median, my Q3, and my maximum. We're going to use that when we make box and whisker plots. We'll talk about those in a minute. These guys are known as my lower and upper quartiles. And I find what's called IQR, you probably can't see me over there, inner quartile range, by doing Q3 minus Q1. Okay, so IQR, Q3 minus Q1. Okay, so 5-number summary. Like I said, we'll use this a little bit later for a box and whisker plot. All of that shows up when we do one var stats on the calculator. Alright, cumulative frequency. It is what it sounds like. Cumulative just means I'm accumulating all of my data. So here it's using the same table that we had above with the ages and the frequencies. So if you have 9 kids who are 14 years old, your cumulative is just 9. It's the first age I'm looking at. But if you have 11 who are 15, you have 20 kids that are 15 and under. Okay? This is accumulating the data. So to get these, I'm just doing 9 plus 11 to get 20, 20 plus 4 to get 24, 24 plus 7 to get 31. Your final number should always be your total number of data points. Okay? Because you've accumulated all of them. This is what a cumulative frequency curve looks like, okay? Most of the time they will give you one rather than you having to create it yourself, but you could create it if you were. You're just plotting basically all of the points in this table. So if I plot the points, 14, 9, 15, 20, 16, 24, 17, 31, that's how this is being created, okay? So see how I'm plotting all these guys. This is for height. This is different than the table up there, but it's following the same pattern. If they give you this and ask you to read it, which is what they're going to do most of the time, the biggest thing that we can find from it are percentiles. So remember, if you get a standardized test score back and it says, congratulations, you scored in the 80th percentile, that means you did better than 80% of the other kids who took the test. So there's 80% accumulated up to your score. Percentiles also come into play with Q1 and Q3 because Q1 is really the 25th percentile, Q3 is the 75th percentile. Your median is the 50th percentile. So if I am using a cumulative frequency curve in order to find my 5-number summary, basically, my Q1 and my median and my Q3, I can look at my total amount. So in this case, there was 120 total. So if I want to find my median, I go halfway up my cumulative frequency, over until I hit my curve, and straight down. It hits my x-axis at 20, and so my median here would be 20 centimeters. Okay? Same thing for Q1 and Q3. So if I have 120 total, 1/4 of that is going to be 30. I go over and down. I hit about 9. That's going to be my Q1. 75% is at 90, over until I hit my curve. Down, I'm about 40, 41. That's going to be my Q3 or my upper. Okay? And then I can find, so here my median was 20, and my IQR was 40 minus 8. They used 8, 9, doesn't matter. There's going to be leeway here for that. Sometimes they'll have tiny little bars and it will hit exactly. Okay? But I want to see these lines drawn over and down. If you know the percentile, so you know you're at 25th, 50th, 75th, you're starting on your y-axis, going over and coming down. Okay? If I ask you what percentile is a height of 30 centimeters at, start on your x-axis, go up, over. It's not at the 80th percentile because it's 80 out of 120. And that's going to give me that percentile. Okay? So that's how I use cumulative frequency charts. We just talked about percentiles and how to find that on the graph. Box and whisker plots. So I mentioned this 5-number summary earlier. Okay? That's how I create a box and whisker plot. I want to point out that when you draw it, it has to have a number line underneath it. You want to draw this first, then plot your box and whisker plot. Otherwise they all look the same and I can't tell my spread of the distribution. Okay? So we have mean, median, and mode, which are all measures of central tendencies, measures of center. And then we have range, IQR, and standard deviation that are measures of spread. It's telling me how spread out my data is. Box and whisker plots are just another visual to help me see where is that center and what's my spread like. Okay. Stem and leaf diagrams. Biggest thing here is that you just know how to read them. It will always come with a key for you. Okay. So it's just saying 512, that means 1.2. A lot of times it will mean 12, but again, it will always come with a key. I always say if you turn this and look at it sideways, it's kind of like a distribution curve, and you can see how it's spread out. All right, but it's basically just giving you all of the data points, 1.2, 1.3, 2.4, 2.9. I could type all those in and find anything that I needed in my calculator. Okay. All right, histogram. Histograms and bar graphs look very, very similar, except histogram bars have to be touching. The reason for that is we use histograms for what's called continuous data. Okay, so in this class we have categorical data and quantitative data. These guys are numbers, and these guys are categories, okay? Just what it sounds like. Within quantitative, though, we have discrete and we have continuous, okay? Discrete is something that has to take on set values. How many A's you get this year, how many siblings you have, how many pets you have. Those are all discrete quantitative values. You cannot get 3.792 A's this year. Continuous, most of the time are going to be measurements, how fast you can run a mile, how tall you are, how much you weigh. So if I'm talking about how fast you run a mile, just because you can't run a mile in 7 minutes doesn't mean you have to then run it in 8 minutes. It can take on any value in between, okay? Which means it's continuous quantitative data. We use histograms for that because there's no break in between. So in this case, anything from 0 all the way up to 2 is going to go in this first bar, and then I immediately jump to the second one. I cannot have breaks in between. A lot of times we'll use a table that has class intervals, okay? So for continuous data, I can't just put, for my time, 1, 2, 3, 4, 5, 6, because there's values all in between those. So I have intervals with a frequency of how many fell within those intervals. If I give you something like this and you are using your calculator to find your 5-number summary, your mean, your standard deviation, anything like that, we use what's called mid-interval values. Okay, so if I'm putting this guy in my calculator, my L2 is still going to be my frequency. That's not going to change, okay? But my L1, I can't put 0 to 2 in L1. So I pick the middle value and say, well, if there were 2 people in between 0 and 2, hopefully it averages out that they all had about 1, okay? So the middle between 0 and 2 would be 1, 2 and 4, 3, 4 and 6, 5, 6 and 7, 8. And this is what I'm going to type in my calculator to find that one variable statistic, where I still have my frequency list, but my L1 are my middle values for all of these intervals, okay? All right, that is the end of these notes. These are on Canvas. You can look through them. There is a whole other set of notes that you can look through. It has some examples worked out. I am going to work through review number 1 next, and then you'll be doing some practice problems on your own this week when the sub is here.